Hello everyone, welcome to the Unacademy. Let's crack GATE ESE with India's largest online learning platform. Get the plus subscription now and start your preparation with India's largest online learning platform with unlimited live and the recorded video lecture. Myself Ajay Das, I'm MTech in Computer Science. I have a 8 plus year of teaching experience. Till now I have trained almost 20,000 engineering students for the GATE as well as training and placement. I have also worked as a freelancer in many reputed institutes of India, and apart from that, I have qualified the GATE exam 5 times, and I have also qualified the Chhattisgarh State Electricity Board exam with the AIR 8 in 2010. Download the Unacademy Learning app and start your preparation sitting anywhere, anytime. So this is the major question which always used to arise in everyone's minds who are preparing for the competitive exam. So what you will get once you will take the subscription of inside the Unacademy platform. So the first thing, you are going to have a daily life classes. Second one is the structure courses, and third one is the live test and quizzes, and the fourth one is unlimited access. And of course, you will have opportunity to learn with the India's top educator. My dear friends, if there is no compromise in educated level, means no compromise in quality, and if there is no compromise in quality, means no compromise in results. So I have just mentioned few of the educators related with the GATE and ESE over here. Like, these are the educators from the electrical, electronics and civil, and similarly from the mechanical and electrical. To know more about the educators, you can download the Unacademy Learning app and you can check each and every educators related with your branch. Now, under the GATE ESE, the Unacademy offering the preparation of GATE ESE in the various branches. You can see over here like the electrical, computer science, mechanical, instrumentation, production, chemical, and so on. So various branches are there. According to your branch, you can get the subscription, or you can suggest your friends who are belonging to the other branches. But once you want to get the subscription, my dear friend, never forget to use the code IFA which is written over here. Please write down this particular code. Never forget to use the code IFA to get any kind of subscription. So here the month-wise subscription fees is already mentioned over here. So suppose if you are looking for the 6 month of subscription, your fees is 20,000, and if you want to go for the 12 month of subscription, your fees will become 25,000. My dear friend, there is a only difference of 5,000. There is only difference of 5,000, means in the 5,000 you are getting additional 6 month of subscription. And in all the situation, either you are taking the subscription of the 6 month or the 12 month, in all the situation you will get minimum 10% discount. So just I have put over here a simple example that if you are getting the subscription of the 12 months and your fees is 25,000, and after getting the discount using this code, your applicable fees will become the 22,500. So this is the much nominal fees which anyone from any background can easily afford. And in this phase, we are preparing you for the GATE as well as ESE. But if you are in a second year or the third year, you must be looking for the GATE 2022. And in that situation, I will advise you to go for 24 month of subscription. My dear friends, once you will compare the fees of the 1 year and 2 year, there is a difference of only 5,000. So logically you can think in this manner, by the 5,000 you are getting one additional year of subscriptions. So this is the good approach. If you are looking for the GATE 2022, go for the 24 month of subscription, because once you will appear for the GATE 2022, after that more many exam will be waiting for you. So it is a good idea to go for the 24 month of subscription. So again, if you will apply this code which is written over here, which is the IFA, immediately you will get the minimum 10% discount. How much? Minimum 10% discount, and your applicable fees will become 27,000. So before leaving the introductory session, I'd like to tell you one more thing, that the code which is written over here, IFA, this is not only applicable for the GATE and ESE. My dear friends, if some of your friends are looking for the CAT, GRE, UPSC, banking, SSC JE, IIT JE, or whatever the competitive exam which is available in Unacademy platform. All of them can use the code IFA, and certainly they will get the minimum 10% discount. So you can suggest your friends, colleagues, relative, everyone to get the subscription using the code IFA, and all of them will get the 10% discount according to their fees. So these are the introduction about the Unacademy platform. Now I start the subject. So as you know, our today topic means discussion concerning discussion is the BFS and DFS traversal into the graph. So before starting any numerical, let's see what is the BFS traversal, what is the DFS traversal, and one more thing I will teach you, what is the topological traversal. Fine, topological. All the things we will see one by one. So, okay, if we are talking about the BFS traversal and the DFS traversal, we basically apply it in undirected graph. Undirected graph. Or you can apply into the directed graph also. Directed graph. Not a problem at all. It should be a graph, it should be a connected graph. You can start either from the undirected or the directed graph, but whenever I am talking about the topological traversal, then it should be applicable in directed graph only. Directed graph. Got it. So first of all, let's see what is the BFS and DFS traversal. So I am starting from the BFS traversal. Let's see the concept, because before solving any numerical you should have a fundamental concept of each and everything. Then only you will be able to solve the numerical. Okay, so just see over here. I am considering a graph A, B, C, D, E, F, G, and in this line. Okay, so this is the simple graph which is given over here, and these are known as vertices and the connecting point is known as edges. So in BFS traversal we basically use Q as a data structure. Q as a data structure. This is the first thing you have to remember. The second thing is we can start from anywhere. We can start traversing from anywhere. From any. Now let's see how, with the help of Q as a data structure, we will start the traversing into this particular graph. See over here. I'm considering a Q. I'm considering a Q. Fine. This is the Q given over here. Of course, you know the property of Q, that we will do the insertion from the rear side and deletion from the rear front side. Okay, so I'm assuming this is the start vertex. This one is the start. So whatever the start vertex is, we will insert the start vertex into the Q. So just insert the start vertex into the Q. Okay, and then what we will do, we will process it. Processing means we are printing this value. So we will process this and we will insert the adjacent vertices of A into the Q. Means the third point is The third point is process start vertex and insert its adjacent vertex into Q. Into Q. Got it. So we have processed the start vertex and we will insert the adjacent vertex into the queue. So what are the adjacent vertices of the vertex A? That is the B, C and D. So this one will be inserted B, C and D. But please mind it over here one more point, that is the we can insert the B, C, D in any order. There is a possibility first of all we will insert the C and then B and then D. So in this manner we have a various possibility, and that's why the BFS traversal of a single graph could be a different. Okay, so more than one BFS traversal are possible for a single graph. Please mind it. Okay, so I'm just considering the one traversing, and then you can assume any other kind of traversing also, because already by this particular method we are able to realize that for a single graph we can have a more than one number of BFS traversal. So next time what we will do, we will process the next vertex. Means how to process? First delete it and then print it. So we are processing the next vertex, that is the D, and these are actually giving us the traversing sequence. These are just giving us the traversing sequence. Got it? These are giving us the traversing sequence. So just process the next vertex and insert its adjacent vertex into the queue. So once you will delete the B, what are the adjacent vertex? That is the A and C. So how we will able to know that A is already visited? So for that reason what we will do, we will construct a visiting table. So here I am just constructing a visiting table. This is known as visiting table. Okay, and in this table we will introduce all the vertices, that is the A, B, C, D, E, F and G. So initially the value of each vertices is 0. 0 means still not visited. But once we will access the vertex A, it will be visited, yes or no? It will be visited first of all, and after that we are accessing the B. So whenever we will access this, means it is visited. So whenever you are accessing the B, means it is visited. Now in this situation, whenever we are trying to access the B, all the adjacent vertices will be inserted into the table. All the adjacent vertices will be inserted into the table. Means whenever we are accessing the B, its adjacent vertices is A and E, out of which A has been already visited. So what we will do, we will insert only E. So we will insert E inside the table. Now what we will do, once we have inserted, means C already we have visited means it is already access. Just see over here. Now whenever we are accessing the C, now we have to access the how to access, just delete it and print it. So whenever we are accessing the C, what are the adjacent vertices of C? The adjacent vertices is A and E, and A and E is already visited and inserted into the queue. So none of the node will be inserted inside the queue with respect to the C. Now Just see, next time we will access the D. So since we are accessing the D, so what are the adjacent vertices of D? That is the A, E and G, out of which A and E is already visited but G is still not visited. So what we will do, we will insert the G over here, and in the table we will mark it as a 1. Okay, now next time we are accessing the E. So whenever you will access the E, what are the adjacent vertices of E? That is the B, C, D and F, out of which B, C, D has been already visited but F is left. So we will mark it as a 1 and we will insert the F over here. Next time we will access the G. The adjacent vertices of G is F and D, which is already visited. So next time we will access the F. So this one will become the traversing sequence. This one will become the traversing sequence. And how the graph will look like? First of all, we have visited to A, then we have visited to B, then we have visited to C, and then we have visited to D. And after the D, we have visited to E, and after the E, we have visited to D. Okay. After the E, we have visited to G, and G must be visited via E. And then after the G, we have visited to F. F must be via, because the F was inserted because of E. F was inserted because of E. That's why we have created this particular S. So this is the particular spanning tree. After BFS traversal. Got it. So in this funda, we will try to solve some of the numerical related with the BFS traversal. Let's see the GATE numerical. Okay, let's see the GATE numerical. This is the question which was asked in GATE 2007. Please try to understand the question first of all, and then we will try to solve the numerical. What the question is asking, a BFS, that is the breadth first search algorithm, has been implemented using the Q data structure. Of course, we will use the Q as a data structure. Which one of the following is possible order of visiting the nodes in the graph below? These are given as the possible order of visiting the nodes. So here we are starting from where? Already inside the question it is given we are starting from the M. Here it is given we are starting from the N. Here it is given we are starting from the Q, and here it is given starting from the P. So we can start from anywhere, and if we are starting from the M, then let's see what is the possibility. Let's see what is the possibility. The first numerical we will solve according to the method, and then we will directly apply the numeric logic. So this is the M. So whenever we are accessing the vertex M, the adjacent vertex will be inserted inside the Q. So definitely we will insert N Q R. This is the N Q R. Either we can insert this, or we can insert the N R Q, or we can insert the Q R N. So whatever the possibility it could be, there will be factorial 3 number of possibility. If there are 3 number of vertices adjacent to the M, then there are factorial 3 number of possibility for inserting these node into the Q. So my dear friends, in any order, once you will insert these 3 nodes, it will be printed over here 1, 2 and 3, means just after the M up to this point only these 3 nodes will be appeared. But here it is given as O, which is not possible. Coming O in this point according to the option is not possible. Is not possible. Are you getting my point or not? All of you. Either in this point will appear the N Q or R. But coming O is not possible because O is not adjacent of M. So this option is false. Similarly, if now we will try to solve the numerical directly. Okay, please try to understand. Similarly, if we are starting from the N, means we have accessed the N, and what are the adjacent vertices of N? These are the M, Q, O, and it is given as QMP. So in this point, P is not possible because P will always come after O. P will always come, or you can say appear after O. After O. P will always come after, uh, just write it properly. Always come after, but before O it cannot be appear over here, because whenever we will insert the adjacent vertices of N, it will be a Q, M and O. So possibility of P is not over here. So this is not a possible sequence. Similarly, just think about the third scenario. So whenever we are accessing the Q, what are the adjacent vertices of Q? This is the M, N, O and P. M, N, O and P means the R will appear at the last moment, but here at the last point P is coming. P is coming, which is just not possible. Which is just not possible. Here this one is not possible, because whenever we will access the Q, the adjacent elements, all the adjacent element will be processed first, and at the last moment R will be processed, but here it is given as P. So this is also not possible. So of course this will be the right answer. If we have remove all the options A, B and C, so the D will become the right answer. So you can check it out, not a problem at all. Just see over here. I'm just thinking on the option D. 1, 2, 3, 4 and this one is 5. So we are starting from the P. So we will access the P and all the adjacent element of P will be inserted. That is the O and Q. So suppose we have inserted the O and Q. Next time we will access the O. Now all the adjacent element of O will be inserted. That is nothing but only N, because uh, Q and P has been already visited. By the visiting table we will be able to realize Q and P has been already visited, so only we will insert the N inside the Q. Now next time we will access the Q. So once you will access the Q, the adjacent element of Q is P, O and M, out of which this node already has been visited, so we will insert the M only. So we will access the N. So after accessing the N, all the adjacent element of N has been visited, so we will access the M, and the adjacent of M is R. So next time we will access the R. So this could be a possible traversing sequence, which is given in the option D. So D will become the final answer. D will become the final answer. Now let's try to solve one of the finest numerical that was appeared in GATE 2016 set 2, and this is of 1 marks. So my dear friends, this is the question which is related with the breadth first search as well as binary tree, basic concept of binary tree. So first of all we will try to read the question very properly, and then we will approach for the solution. So let's see over here. What the question is asking, the BFS is started on a binary tree beginning from the root vertex. Okay, fine. There is a vertex T at the distance 4 from the root. So my dear friends, if this is the root node, then at the distance 4, this could be a node T. If this is the root node, then at a distance 4. So from here to here, what are the distance I'm assuming? I'm assuming the distance 4 over here. So 1, 2, 3, 4. So according to the question, there is a vertex T at the distance 4 from the root node. Okay. So according to the question, I have created a binary tree. I have created a binary tree. Of course, it is a skew binary tree. Okay. Now see, if T is the nth vertex, what the question is saying, this one is the nth vertex. Okay. In this BFS traversal, then the maximum possible value of n is so in this situation, if you will start the BFS traversing, from here, suppose that this is the vertex 1, 2, 3, 4 and 5. So when this particular vertex will be accessed, so first of all we will access the 1, then 2, then 3, then 4 and then 5. So at the 5th point we will access this particular vertex, and what they are saying, if T is the nth vertex in this BFS traversal, then the maximum possible value of n. So of course the maximum possible value of n over here is 5. If the graph will look like this, if the graph will look like the skew binary tree, we are getting the value of n is equal to 5. Now we are making the graph like this. Please try to understand. We are making a full binary tree. We are making a full binary. Okay. Okay. So from here to here, what is the distance? I'm assuming the distance is equal to 4. Now let's try to understand. At the distance 4, any one of the node could be happen. At the distance 4, these all nodes are at the distance 4. But what they are asking, please try to understand the question. They are asking the maximum possible value of n. So if you will assume any intermediate node as a nth point or the point T, if suppose you are assuming this node is at a distance 4, this node is a T and which is at a distance 4. Of course, this is also a correct thought process. And this node is also at a distance 4. And this node is also, this node if you are assuming T, then it is also in a distance 4. But what they are asking the maximum possible value of n. Maximum possible value of n means after which time it will be what is the maximum possibility that it will be accessed at the last point. So कोई भी नोड, किसी भी तरह का नोड हो, वो किस पॉइंट पे जाकर करके एक्सेस होगा. अगर आप इसमें से किसी को भी मान लेते हो इंटरमीडिएट नोड, तो ये एक्सेस कब होगा, इसको मानते हो तो कब होगा, इसके मानते हो तब कब होगा. तो देखिए इस तरह के क्वेश्चंस को समझने के लिए एक छोटा सा एक्सप्लेनेशन को समझिए. ग्राफ का स्ट्रक्चर थोड़ा सा छोटा लीजिए. ये हमने ग्राफ का स्ट्रक्चर लिया है. यहां पर ये जो वर्टेक्स है 1 है, 2 है, 3 है, 4 है, 5 है, 6 है, 7 है. तो यहां पर लीफ नोड पे जितने भी नोड है वो सभी डिस्टेंस कितने पे है, 2 पे है. फाइन. तो आप T इसको भी एज्यूम कर सकते हो, T इसको भी एज्यूम कर सकते हो, T इसको भी एज्यूम कर सकते हो, इसको भी एज्यूम कर सकते हो. लेकिन अगर इस ग्राफ में हम लोग BFS ट्रैवर्सल इस रूट नोड से स्टार्ट करते हैं, तो देखिए सबसे पहले 1 एक्सेस होगा, 1 के एडजेसेंट नोड Q में इंसर्ट होंगे, दैट इज द 2 and 3. नेक्स्ट टाइम वी विल एक्सेस द 2 and then these two nodes will be inserted into the queue, that is the 4 and 5, and then we will access the 3. अब 3 के जो adjacent node है 6 and 7 will be inserted into the queue. सो एट दिस पॉइंट दिस विल बी एक्सेस, इस पॉइंट पे ये एक्सेस हो जाएगा और यहां पर n का वैल्यू कितना आ रहा है, 4 आ रहा है। यहां पर n का वैल्यू कितना आ रहा है, 4 आ रहा है, बिकॉज इफ यू हैव एज्यूम दिस इज द t पॉइंट, then the value which is coming out to be 4. But if you will assume this is the t point, then it will be access over here और यहां पर n का वैल्यू कितना आ रहा है, 7, क्योंकि ये सबसे लास्ट में एक्सेस हो रहा है। देयर इज अ पॉसिबिलिटी कि आप इस तरह से एक्सेस कर दो 1 2 3 4 5 and then 7 and then 6, but in this situation what is happening, it is accessing at the point n is equal to 6. So one time you are getting the n is equal to 7 and the second time you are getting the n is equal to 6. Out of this, if someone will ask you the maximum of 6 comma 7, so it will be a 7. So maximum possibility access करने का इसका क्या है, तो this is the 7th point पे। लेकिन इसके बीच में इंटरमीडिएट जितने भी नोड है, अगर आप इसको t एज्यूम करते हो तो वो कभी भी 7th पॉइंट पे जाकर करके एक्सेस होने की पॉसिबिलिटी कम है, ठीक है ना। 7th पॉइंट पे जाकर के एक्सेस होने की पॉसिबिलिटी कम है। सो सिमिलरली इफ दिस इज द nth पॉइंट और दिस इज द nth पॉइंट और द नोड t, देन मैंने सबसे पहले इसको एक्सेस किया, सेकंड में ये होगा, थर्ड में ये एक्सेस होगा, फोर्थ में ये एक्सेस होगा, फिफ्थ में ये, सिक्स्थ में ये, सेवेंथ में ये, देन 8 9 10 11 12 13 14 एंड 15। और अगर ये 8 में एक्सेस हो रहा है तो ये 9 में 15, ये कितने में एक्सेस होगा, 16 17 एंड अप टू डॉट डॉट डॉट, ये कितने में एक्सेस होगा, 31। So here the value of n will become 31. So this is the maximum possibility. This is the maximum possibility. और maximum possibility कब arise होगा, when the binary tree is a full binary tree. The maximum value you will achieve whenever the binary tree is a full binary tree. But if it is a skew binary tree, it will give you the minimum possibility. It will give you the minimum value of n, which is nothing but 5 over here. And if the binary tree is the full binary tree, it will give you the maximum value of n, which is 41 over here. So the right answer of these questions will become 31. Got it, everyone? So I hope you enjoy this particular concept, and from the next time whenever the questions will be asked from the similar concept, you are not going to make any mistake. Okay, now let's come to the another thing. Till now we have learned about the BFS traversal. Now see the DFS traversal. DFS, the full form of DFS is depth first search. Okay, so in case of DFS traversal, it uses stack as a data structure. So my dear friends, why we use the stack? In any situation, why we use the stack? Because you have learned about the things. What is the application of stack? Okay, already I'm just giving you two different applications. In PDA you have already used the concept of the stack, that is the push down automata, and again in recursion we basically use the concept of the stack. So why we are basically using the stack? To memorize all the previous calls. Okay, the stack is basically implemented to memorize all previous calls, or you can say, are you getting my point? All the previous calls are recorded. How we will understand this? How the stack is basically used to memorize the previous calls or the record. So let's try to understand. Suppose take a real life example. Suppose this is the point X, and one person has started a journey from this particular point, and it has visited to the point Y, and from the Y it has visited to the point Z, and from the Z it has visited to the point W. Now the same person, after visiting the point W, he wants to return back to the point X. So how it will be returned from the original point? So for that reason, means you need to backtrack. This is called the backtracking. You need to backtrack on the same path. You need to backtrack on the same path, and for the backtracking you need to memorize all the visiting place. You need to memorize all the visiting place so that you can easily backtrack to the original point. So what we will do, once the person will leave the location X, once the person will leave the location X, it will immediately insert the location of X into the stack. So once it will reaches to Y, and before leaving the place Y, what it will do, it will insert the location of Y. Similarly, before leaving the place Z, it will insert the places or the location of Z. Now since the person is not moving anywhere from the point W, so the location of W will never be inserted into the stack. Now this same person wants to backtrack to the original point X. So what he will do, he will look upon the top of the stack symbol, and by looking upon the top of the stack symbol, he will be able to realize last visiting place, last visited place. So just looking upon the top of the stack, he will be able to know that the last visited place, my last visited place is Z. So looking upon the Z, it will reach to the Z, and once he will reach to the Z, he will pop the top of the stack symbol. He will pop the top of the stack symbol. So this one will be popped, and the next content of the stack will become X and Y. So once he has reached to the Z, he will again look upon the top of the stack symbol, which is the Y. So immediately he will be able to realize my previous visiting place was Y, if I was in Z. So immediately he will remove the Z and he will reach over. So once you will remove the Z, the top of the stack symbol will become X. So looking upon the top of the stack symbol, again he will visit to the X. He will visit to the, are you getting my point or not? So this is the application of the stack. So with the help of a stack, what we are doing, we are memorizing all the visited place. We are memorizing all the visited place. Similarly, in the PDA, we basically memorize all the previous scanning, so that we can scan either the same number of input symbol or the same symbol. Okay, in case of recursion, we basically need to store all the activation record. Whatever the recursive call you are making, you need to store all the recursive record or the activation record inside the stack. So basically, stack is basically used to memorize the previous calls. So let's see how we are going to apply the concept of a stack for the DFS traversal. For the DFS, I'm just considering a graph A, B, C, and then E, F, and from here to here it is a G. Okay, and suppose it is given as this is the start vertex. Of course, you have to know the start vertex for the traversing. So A is the start vertex. So how we will use the stack? See over here. Since A is the start vertices, so we will insert the A into the stack. So once you have inserted the A into a stack, means you have visited the A. So first of all, A will be processed. A will be processed. means you have visited the A, means you have to push the vertex A into the stack, means you have visited the stack. This is nothing but a traversing sequence. Here I'm just describing the traversing sequence. Okay, here I'm just describing the traversing sequence. So first of all, we have traversed the A, means visited the A. Now what is the adjacent vertices of A? The adjacent vertices of A is B. So immediately we will reach to the B. We will reach to the B, means next time we have accessed the B. Now what are the adjacent vertices of B? It is F and C. So either you can visit to the F or you can visit to the C. Suppose we have visited the C. So push the C into the stack and process it. So C will be processed. Okay. So still F has not been visited. So of course for that reason you have to create a visiting table. Whether the node is visited or not, for that reason you have to create a visiting table. So this is the A, B, C, D, E, F and G. Since we have visited the A, mark as 1, again 1, again 1. The remaining are 0, or you can say the blank. Okay. So once you have accessed the C, again the adjacent vertices of C is B, D and E, out of which B is already visited. So no need to go over here. So you have only two options. Either you can visit to the D or you can visit to the E. Suppose we have visited the D. So D will be processed. D will be processed. Now once we will come to the D, means एक पर्टिकुलर पॉइंट पे हम लोग किस नोड पे हैं ये पता चलता है टॉप ऑफ द स्टैक से. इन अ पर्टिकुलर पॉइंट इन विच नोड यू आर, it will be indicated by the top of the stack symbol. Got it? So the top of the stack symbol is D, means we are in this particular point. The person is standing in this particular point. Now what is the adjacent vertices of D? That is the C only. और देखिए किसी भी वर्टेक्स का एडजेसेंट वर्टेक्स कौन है इसको कैसे पता करेंगे? यू हैव अ टू डिफरेंट मेथड. ईदर मींस हाउ टू रिप्रेजेंट अ ग्राफ. किसी भी ग्राफ को हम लोग दो तरीके से रिप्रेजेंट करते हैं. एक हो गया आपका एडजेसेंसी मैट्रिक्स, ठीक है ना. द सेकंड मेथड इज एडजेसेंसी लिस्ट. So looking upon the adjacency matrix, you will be able to identify which is the adjacent vertex of a given vertex V. So D vertex का adjacent vertex कौन है हम लोग adjacency matrix में चेक कर सकते हैं. And it is a C. And C is already visited. So what we will do? अब हम लोग यहाँ पर D पे है तो मुझे यहाँ से बैक ट्रैक करना होगा. अब बैक ट्रैक करने के लिए क्या करना होगा आपको? यू हैव टू पॉप द टॉप ऑफ द स्टैक सिंबल. सो वंस यू विल पॉप द टॉप ऑफ द स्टैक सिंबल, यू विल कम टू द प्रीवियस विजिटिंग नोड. भाई डी के एडजेसेंट में सी है और सी ऑलरेडी विजिटेड है, तो आपको क्या करना पड़ेगा? इसके आगे कोई रास्ता नहीं है, और अगर इसके आगे कोई रास्ता नहीं है तो यू हैव टू कम बैक टू द सी. एंड हाउ यू विल रीच टू द सी? मींस सी हमारा यहाँ पर क्या है? लास्ट विजिटिंग नोड है. And how you will come back to the C? Once you will pop the top of the stack symbol, you will immediately reach to the next top of the stack symbol, which is nothing but C. So once you have popped D, you have reached to the C. और इस तरह से क्या हो गया? यहाँ पर बैक ट्रैकिंग हो गया. Now again, what is the adjacent vertices of C? That is the B, D and E, out of which B and D has been visited. So looking upon the visiting table, you can easily realize whether the given vertices has been visited or not. So we have come back to the C, and B and D is already visited. So next time we will visit to the E. So since we are visiting to the E, just push it into the stack and just process it, means print it. Okay, so we have reached to the E. फिर यहाँ से यहाँ हम लोग आ गए. अब ई का एडजेसेंट वर्टिसेस कौन कौन सा है? सो इट इज अ सी एफ एंड जी, सी एफ एंड जी, आउट ऑफ विच सी हैज बीन एक्सेस और you can say the visited. So definitely you are looking for the f and f or g. So suppose we have inserted the g, we have inserted the g. So since you have inserted the g, just process it. So g को मैंने जैसे ही प्रोसेस कर लिया, we have reached to the g. यहाँ पर ये पर्सन आ चुका है, ठीक है ना. अब g का एडजेसेंट कौन है? ओनली e. e जो है, ठीक है ना, e और यहाँ पर g, इन दोनों को मार्क कर दीजिए. तो e ऑलरेडी एक्सेस हो चुका है. तो since e is already access and adjacent vertices of g is e only, what we will do, we will pop this. और इसको आप जैसे ही पॉप करोगे, नेक्स्ट टॉप ऑफ द स्टैक सिंबल कौन है? नेक्स्ट टॉप ऑफ द स्टैक सिंबल कौन है? दैट इज द e. That is the e. So the person will again come back to the e. So person will come back to the e. Means by popping this, we are visiting to the previous vertex. We are reaching to the previous vertex. And कैसे हो रहा है ये? बैक ट्रैकिंग की हेल्प से हो रहा है, ठीक है ना. तो now the top of the stack symbol is e. So what is the adjacent vertices of e? That is the c, g and f, out of which c and g has been accessed. So next time किसको एक्सेस करेंगे? f को. तो जस्ट मार्क इट, जस्ट मार्क इट. तो यहाँ पर हम लोगों ने f को एक्सेस किया, ठीक है ना. तो यहाँ पर f प्रिंट होगा. चलिए, अब f का एडजेसेंट वर्टिसेस कौन है? Now the adjacent vertices of f is b and e, out of which b and e has been already visited. So we will pop this. तो पॉप करने के बाद फिर से हम लोग बैक ट्रैक करके यहाँ पर आ रहे हैं. Now the top of the stack symbol is, now top of the stack symbol is क्या दिया हुआ है? e, c, e and now top of the stack symbol is e. So we have reached to the e. And what is the adjacent vertices of e? c, g and f, जो कि सभी विजिट हो चुके हैं. तो again we will pop e. So once you will pop e, you will backtrack to the c. Similarly, now this is the top of the stack symbol. So adjacent of c is b, d and e, जो कि सभी विजिट हो चुके हैं. So again we will pop c. So once you will pop c, again you will backtrack to the b. So we will come to the b, and adjacent of b is c, f and a. c, f and a, these are the adjacent of b, जो कि सभी विजिट हो चुका है. तो again we will pop the b and we will reach to the a. So at the last moment, the top of the stack symbol will become. So after the traversing, if you are reaching to the start vertex, means the traversing has been completed. After the entire traversing, if you are reaching to the start vertex, means the traversing is completed. Here traversing is completed because we are reaching to the, we have reached to the start vertex, and this one will become the traversing sequence. Got it? So यहाँ पर हो क्या रहा है? Why the name, the depth for search, depth for search is given. सबसे पहले हम लोग एक डेप्थ तक जाते हैं, ठीक है ना. जैसे कि A से हम लोग B पे गए, B से C पे गए, C से D पे गए, ये डेप्थ है. अब इसके बाद कोई नोड नहीं है. डेप्थ का मतलब क्या होता है? अब इसके नीचे कुछ नहीं है, ठीक है ना. अगर आप जमीन के गहराई तक जाते हो, डेप्थ तक जाते हो, तो कहीं पर बालू भरा होगा, मीन्स उसके आगे कोई जाने का रास्ता ही नहीं है. तो दैट इज द मैक्सिमम डेप्थ. वहां तक मैंने सर्च कर लिया, अब उसके बाद कोई रास्ता नहीं है, तो आपको तो बैक ट्रैक करना पड़ेगा ना. देन अगेन यू हैव टू मूव टू द नेक्स्ट डेप्थ. तो फिर सी के बाद हम लोग कहां पर गए? जी पे गए. यस और नो? देखिए, सबसे पहले हम लोगों ने ए से स्टार्ट किया, बी पे गए, सी पे गए, फिर डी पे गए. इसके आगे कोई रास्ता नहीं है. बैक ट्रैक करके फिर हम लोग ई पे गए, ई के बाद हम लोग जी पे गए. तो दिस इज द मैक्सिमम डेप्थ. देयर इज नो अनदर वर्टिसेस. अगेन वी विल कम बैक and we will go to here, and in this point this is the maximum depth. So how the graph will look like? It will look like this: A, B, C and D. यहाँ पर ये डेप्थ खत्म हो रहा है. उसके बाद C से फिर से हम लोग E पे गए, और E से हम लोग फिर से G पे गए. अब ये मैक्सिमम डेप्थ है. फिर बैक ट्रैक करके हम लोग आएंगे और E से F पे जाएंगे. So the graph will look like this. क्लियर है बात? Now let's come to the numerical. Let's come to the numerical part. Okay, see over here. See over here. So this is the one of the interesting numerical that was asked in GATE 2014. My dear friends, please try to understand. But before solving this numerical, I will suggest you to solve this numerical first. This numerical first. Before solving that numerical, I will suggest first of all solve this particular numerical which was asked in GATE 2008. So please try to understand. Of course, डेप्थ फर्स्ट सर्च जो सीक्वेंस होंगे वो एक से ज्यादा हो सकते हैं, यस और नो? मीन्स इस एग्जांपल में हम लोगों ने क्या नोटिस किया है, ए के बाद हम लोग बी पे आ रहे हैं, बी के बाद वी कैन इधर मूव टू सी और वी कैन मूव टू एफ. तो अगर हम लोग ए के बाद बी, बी के बाद एफ पे जा रहे हैं तो एफ से ई पे जाएंगे, ई से जी पे जाएंगे, तो ये भी एक अलग सीक्वेंस पॉसिबल है. तो डेप्थ फर्स्ट ट्रैवर्सल हो या ब्रेथ फर्स्ट ट्रैवर्सल हो, more than one sequence are possible. So just please remember this. Okay, note down it. There could be more than one BFS or DFS traversing sequence possible for a single graph, for a single graph G. Always remember this. Okay, now let's come to the GATE 2008 numerical. Let's come to the GATE 2008 numerical. So just see over here. Consider the following sequence of node for the undirected graph. The graph is undirected graph given below. Okay, so these are the sequence of node which is given. Now DFS, that is the depth first search, is started at the node A. We have started the DFS traversing from the A. The nodes are listed in the order they are first visited. Okay, यहाँ पर listed किया गया है 1, 2, 3 and 4. Okay, which of the above is are possible outputs using the DFS traversal? Which all of the above is are possible outputs using the DFS, that is the depth first search traversing sequence. So see over here, हम लोग यहाँ पर A से स्टार्ट कर रहे हैं, ठीक है ना. A के बाद यहाँ पर B दिया हुआ है, तो चलिए ये पॉसिबल है. A के बाद हम लोग B पे चले गए, B के बाद ये E दिया हुआ है, तो ऑफ कोर्स B के बाद हम लोग E पे जा सकते हैं, ठीक है ना. एक पर्टिकुलर डेप्थ तक जाना है, ठीक है ना. E के बाद हम लोग F पे जा रहे हैं, तो E के बाद हम लोग F पे जा रहे हैं, दिस इज ऑल्सो पॉसिबल. F के बाद हम लोग D पे जा रहे हैं, तो भाई F के बाद या तो आप C पे जाओ या तो आप G पे जाओ, बट डायरेक्टली इफ देयर, ये तो हमारा मैक्सिमम डेप्थ नहीं है ना, क्योंकि F के बाद हम लोग C पे भी जा सकते हैं या G पे भी जा सकते हैं. बट व्हाट इट इज रिटन ओवर हियर, फ्रॉम द F वी आर मूविंग टू द डायरेक्टली D. तो D तक जाने के लिए हमको यहां से बैक ट्रैक करना पड़ेगा. सो देयर इज नो नीड ऑफ बैक ट्रैकिंग. Are you getting my point or not? There is no need of backtracking because there is more depth also. So this is not a possible sequence. Now let's check similar in a similar form the next sequence. See over here, we are starting from the A and we are migrating to B. Of course this is possible. From the B we are migrating to the E. This one is also possible. From the E we are migrating to the F. This is also possible. From the F we are migrating to the C. So of course this is the maximum depth, क्योंकि C के बाद B E फिर से तो नहीं आएगा क्योंकि ये ऑलरेडी विजिट हो चुका है. So in this situation what we have to do after accessing the C, we need to backtrack. अब बैकट्रैक करने के बाद नेक्स्ट जो एक्सेस होगा, C को बैकट्रैक करने के बाद नेक्स्ट जो एक्सेस होगा that will be a G. Yes or no? That will be a G. So यहाँ पर G गिवन है और G के बाद जो हम लोग एक्सेस करेंगे that will be a सारा का सारा नोड विजिट हो चुका है. So of course this traversing sequence is possible. Similarly, you have to think about the option C. A, so we are starting from the A, then D, we are marking from the green color, okay, D, and after D we are visiting to the G, also this is possible, and from the G we are traversing to the E, of course this is also possible. From the E we are traversing to the B, of course this is also possible, okay, and from the B we are traversing to the E, C, this is also possible, and from the C we are traversing to the F, this is also possible, means this one is possible. Similarly, let's think about this option. So we are starting from the A to B, A to B, this is possible, and then B, D to B, this is possible, B to C, this is also possible, and then C to G. How you can move from C to G? How you can move from C to G? Because there is a depth F also. So either you can move to the F or you can move to the E, but directly you cannot jump to the G. So this one is not possible. So according to this, what will be the correct answer? 2 and 3. 2 and 3 will be the correct possible DFS traversing sequence. So the right answer will become B. So the right answer will become B. So I hope you understand this concept, and from the now onwards, whenever the question will be asked either from the BFS or the DFS, you are not going to make any mistake. Now let's come to the actual problem. This one, GATE 2040. Okay, set 3, 1 marks. Please read the question very properly, क्योंकि सभी जितने भी चीजें हैं वो क्वेश्चंस के अंदर ही छुपे हुए होते हैं. तो अगर आपको क्वेश्चन समझ में आ रहा है तो आप कभी भी गलती नहीं करोगे, और अगर आप गलती नहीं करना चाहते, then my dear friends, never forget to use the code IFAR to get minimum 10% discount. For any clarification, you can personally text me a message in my Telegram number, that is the 9264954515. Okay, now let's see the question. Suppose depth first search is executed on the graph below, starting at some unknown vertex. Some unknown vertex. We don't know what is that vertex from where we have to start the depth first search traversal. Okay, fine. Assume that a recursive call to visit a vertex is made only after first checking that that vertex has not been visited earlier. यही तो हम लोग करते हैं. ये तो हम लोग करते हैं भाई, किसी भी वर्टेक्स में तो ही विजिट करना है अगर वो प्रीवियसली विजिटेड नहीं है. और इसके लिए हम लोग क्या करते हैं, वी बेसिकली क्रिएट द विजिटिंग टेबल. ओके, व्हाट द क्वेश्चन इज आस्किंग, द क्वेश्चन इज आस्किंग अबाउट द मैक्सिमम पॉसिबल रिकर्सिव डेप्थ. सो व्हेनेवर वी आर यूजिंग द स्टैक, इट विल क्रिएट अ रिकर्सिव डेप्थ. मीन्स जो भी रिकर्सिव डेप्थ है वो हम लोग कहाँ मेंटेन करते हैं, स्टैक में ही मेंटेन करते हैं. So what they are asking, the maximum possible recursive depth including the initial node is. So my dear friends, you can start from any unknown vertices. So suppose we are starting from here. Please try to understand. We are starting from here. This is, I am assuming this is the start vertex. So of course, from the 1 we will reach to the 2, means it should be inserted inside the stack, and from the 2 we are reaching to the 3, then 4, then 5, then 6, then 7, then like you just take in this manner. Okay, you don't access this, then 7, then 8, then 9, then 10, then 11. So after the 11, all these vertices has been visited. So what you have to do, you have to backtrack over here and you have to insert this. So it will be inserted into the 11th position of the stack. So by the marking I, it basically represent size of stack. Okay, or the size of a stack, or you can say the recursive depth. Recursive depth. Okay, so from the 10 you are visiting to the 11. In this point, are you getting my point or not? इस पर्टिकुलर पॉइंट पे जो स्टैक का साइज होगा वो 11 होगा, और इसके बाद कोई भी नया अनविजिटेड नोड नहीं है, तो हम लोग फिर यहाँ से बैक ट्रैक करके यहाँ पर आ जाएंगे। जब हम लोग यहाँ पर आएंगे तो इस पॉइंट पे स्टैक का साइज कितना होगा, 10 होगा, और इस 10 से यहाँ पर जाएंगे तो इस नंबर से हम लोग इंडिकेट कर रहे हैं कि स्टैक का साइज कितना होगा, रिकर्सिव डेप्थ का साइज कितना होगा, दैट इज द 11। तो यहाँ पर 11 आ रहा है। अगेन हम लोग क्या करेंगे, बैक ट्रैक करेंगे और बैक ट्रैक कर करके यहाँ पर आ गए, ठीक है ना। तो फिर से स्टैक का साइज कितना हो गया, 2 हो गया, और फिर आप यहां पर मूव करोगे। तो इस पर्टिकुलर सिचुएशन में इफ दिस इज द स्टार्ट वर्टेक्स, देन इन दिस पर्टिकुलर सिचुएशन द साइज ऑफ recursive depth is equal to 11 we are achieving. The size of recursive depth is 11 we are achieving. लेकिन आपसे पूछा क्या जा रहा है, आपसे पूछा जा रहा है मैक्सिमम पॉसिबल रिकर्सिव डेप्थ। सो माय डियर फ्रेंड्स, अगर मैक्सिमम वैल्यू गेन करना है तो सोचने का तरीके को भी बदलना पड़ेगा। तो चलिए अब हम लोग सोचने के तरीके को बदलते हैं। सपोज वी हैव स्टार्टेड फ्रॉम हियर, ओके। तो अगर यहां से स्टार्ट कर रहे हैं तो ये एलिमेंट, ये जो वर्टेक्स है ये स्टैक पे पुश होगा, देन सेकंड नंबर पे ये पुश होगा, थर्ड नंबर पे ये पुश होगा, देन 4, देन 5, देन 6, देन 7, देन 8, अगेन हियर 9। इसके आगे कुछ नहीं है तो यू हैव टू बैक ट्रैक। तो फिर से रिकर्सिव डेप्थ कितना हो गया, 8, देन 9, 8, देन अगेन 9, देन 10, और यहां से आप यहां जाते हो तो ये 11 होगा। फिर से आप बैक ट्रैक आपको करना ही पड़ेगा क्योंकि आगे कोई भी अनविजिटेड वर्टेक्स नहीं है। अगेन यू रीच टू द 10, देन इट विल बिकम 11, 12, 13, 14, 15, 16, and then 17, and then 18, and then 19। अब इसके बाद कुछ नहीं बचा, तो ये हमारा क्या होगा, this one will become maximum recursive depth। ये कितना आ रहा है भाई, 19। if we are starting from the vertex this, so what will be the right answer? This is the numeric type questions, and the right answer you have to put inside the box is, got it everyone? So I hope you enjoyed this particular concept also। और इसके बाद मुझे जहां तक लगता है कि आप लाइफ में कभी भी गलती नहीं करोगे। कोई भी क्वेश्चंस, इधर इट इज फ्रॉम द DFS और द BFS। एंड माय डियर फ्रेंड्स, इस पर्टिकुलर टॉपिक से जो आज मैंने कवर अप किया, यहां से गेट हमेशा गेट एक क्वेश्चन आपसे पूछता है। ये या तो 1 मार्क्स का हो सकता है या तो 2 मार्क्स का हो सकता है, but one question definitely they will ask। So attending the today's lectures, you are going to secure 1 to 2 marks in your GATE exam। So thank you very much। This is all which I wanted to discuss in my today class। And before leaving the session, again I will tell you, or I will suggest you, never forget to use the code IFA। Just write over here, आप इसे लिख लो, दिमाग में बैठा लो, ठीक है ना। Never forget to use the code IFA। Once you will apply this code, you will get the minimum 10% discount। And for more clarity about the minimum, you can personally text me on my Telegram number, 9264954515, and immediately you will get minimum 10% discount। Hit the bell icon button to get all the notification in future। If you want to attend more of my lectures, then press the bell icon button to get the notification। Never forget to subscribe the channel, because this is one of the channel where you can put your all the doubts, and we are trying our best to solve all your doubts related with the GATE problem, or it is a like predictable problem। Next, put your valuable comments, because your one valuable comments will inspire the many students. Okay, so thank you very much guys. Take care, bye and good night.